Hello, everyone. Welcome back to the afternoon session, our final session of ISART. Thank you, everyone, for attending, and I hope you enjoyed our first session today and the interaction with the panelists. Hopefully you took advantage of the break to grab a little lunch, maybe take a nap, do some networking to prepare yourself for this session. This afternoon, we will be bringing it all together. We have a panel of polymaths, and I don't use the term lightly. I think you'll find this panel will expose you to some seriously out-of-the-box thinking and suggest some radical new ideas to you. Our moderator for this panel is Dr. Pierre Vries. I could go on for quite length on his qualifications. Let me just stop it. He is the co-director with Dale Hatfield of the Spectrum Policy Initiative at the Silicon Flatiron Center at the University of Colorado, Boulder. I've had the pleasure of working with Pierre for the past several years, and I will tell you it's hard to keep up. He's passionate about spectrum issues and just has a very, very broad point of view on things. So at that, I'll turn this over to our speaker, Pierre, who will introduce the other distinguished panelists.
Great, thank you very much, Keith. And welcome back, everybody. This is the So What panel. Our goal is to try and take all the what is so that you've heard and try and make some sense of it, give you some perspective on it. I will just briefly introduce the speakers by name and title. If you want all the detail about them, you can look at the PDF you got in email or look in the app, look at the website. As you can see on the screen, this is the old white guy panel. Although actually I should, Doug would say he's not old. Hopefully we are diverse in other ways. Let me just go through the list. So Blair Levin, he's a senior fellow at the Brookings Institution and equity analyst at New Street Research. Paul Kolodzy is an independent telecommunications consultant and a member of the CSMAC. Doug Sicker is a professor of computer science and senior associate dean of computing at the University of Colorado. And David Tennenhouse is chief research officer at VMware and a member of the FCC TAC. Just a reminder for everybody, both the panelists and the audience, when you do Q&A, please define your acronyms. You might think, we're all experts here. We know what all the acronyms meant, but we actually had a case this morning where the acronym DSS has two distinct meanings: distributed spectrum sensing and dynamic spectrum sharing. And so it'll help everybody if you define your acronyms. So that's where we are. What I'd like to do is to just start and have each of the panelists just give us 4 or 5 minutes sense of what they think is important, what they've taken away from the conference so far. And we'll start with Blair. Over to you.
Thank you so much, and thank you for having me. It's really been fascinating listening to everything. I think I'd like to just start off by first pointing out that I'm like one of the few non-engineering types, American Studies major in law school, and so my observations kind of come from that different world, but they're in an effort to translate a lot of the discussion into different worlds. I'll start with a political observation and then ask 2 questions. The observation that I'd like to make is that zero trust is really a bad name. I understand the point, and I think it is accurate in terms of communicating an engineering point, but I will simply point out that I don't know that the public wants to buy zero trust networks or politicians want to support zero trust networks. And I would just note that when I was working with Doug and many others on the National Broadband Plan, one of the things we did was we got rid of the so-called high cost fund because we realized that actually was a pretty horrible name. Nobody wants to contribute to a fund to increase high costs, and we changed it to the Connect America Fund because we thought everyone would like cabs, But that actually was the point, to connect all of America. It's now been changed to the Rural Digital Opportunity Fund because the current FCC thinks that that's really what its meaning is. But talking about how zero trust is a problematic name really leads to the 2 far more important questions, which are how does this discussion translate to capital markets, where I spend most of my time these days? And then secondly, how does it translate to policy and political institutions? In terms of capital markets, I think it's really important to understand, as I think everyone does, that the best technology doesn't always win. Of course, many of us here, certainly people my age, can remember the battle between Betamax and DHS, where the ultimate winner was not the best technology. But it's also true that next generation tech doesn't always justify consumer change. And I think one of the problems from a capital markets perspective about 5G and all the incremental CapEx is, what are consumers really buying? What's the compelling use case? Clearly, there's a compelling use case in terms of certain business applications. But as of yet, we haven't seen any with consumer. And then, of course, that might change. But my point is, a lot of the discussion doesn't go to what is a consumer proposition. I'm sure we'll talk about that more. Security is one of those interesting things. It's really not an issue as far as we can tell for consumers until it's the only issue. But by then, you're in a very different situation. The second point I would make is, how does it translate to policy and political institutions? And I will just say, I'm going to try to avoid making any partisan points, though it may sound like I am making a partisan point. There is a growing distrust of expertise in Washington, D.C. and around the country. We see this obviously with COVID, but we've seen it with a lot of other areas as well. And we've seen it a lot in the area of spectrum, where there have been these huge battles between the FCC and other government agencies that we used to be kind of resolved quietly through expertise and through engineering. And it's not really being done that way. And you saw it, I think, most recently when a senator, the senator from Oklahoma, was holding up the Republican Commissioner Mike O'Reilly, because O'Reilly voted for something which was not only approved by the Office of Engineering and Technology, but approved by all five of the FCC commissioners, a very bipartisan approach, and it was totally about an engineering question. And the senator said, unless you change your mind on the engineering, I'm going to hold up your nomination and you will not be reconfirmed. That's kind of, that's totally within the senator's rights, but it kind of violates the norms. And the reason I make that point is, as we try to convince the FCC and other agencies about the importance of adopting certain points of view, we have to understand its implications on kind of the current populist politics, forcing people to effectively pay more for certain kinds of things. And that's going to be a problem. And I think as we think about the next administration, whether it be a second term or a first term, translating good engineering into good policy through that political filter, and I think zero trust is one of those things that's going to have to go through that. That's going to remain a difficult challenge. Pierre, back to you.
Thanks, Blair. I just want to pick up on something you said. We'll come back to this whole question of zero trust, but I was fascinated when you said, what's the consumer value proposition? Wall Street isn't seeing the value proposition. What does that mean, gut feel for you, about the adoption of 5G? Because the carriers will only adopt what they can pay for, and they can only pay for what Wall Street will fund.
Yeah. So what it means to me is that fundamentally 5G is going to be rolled out in business centers, high density areas. There is a certain cachet, as there was a few years ago with gigabit networks, where there's a certain percentage of people who have a lot of discretionary income and simply want the best available service. And 5G is that thing. But I think that, that ends that order of magnitude. You could say 15% of the consumer market, 30%, but it ain't higher. And particularly in a post-COVID environment where you have people who really are going to be, a lot more about Walmart than Nordstrom's. I think 5G uptake is going to be enormously problematic. And I just think that means that the networks aren't going to be built out as quickly in suburban, exurban, and certainly rural areas. Because again, there's I'm welcome to be corrected, but do not see a compelling single application where people are going to say, oh, we must have that. Some people say that was true of 4G. It actually wasn't. 4G, it was always going to be about video. It turned out there were other applications like Uber and some things that proved very valuable. But the market for 4G was always pretty clear.
Great, thanks. Let's move on to Paul. Paul, I think you may be muted.
Thanks, Pierre. Thanks for reminding me. First of all, it's great to be at a conference where you pick up a few new things, some new ideas and some new thoughts and some new work. And so I actually got some of that out of this meeting. So that makes it a win just in its own right. I think that, as we already said, the goal of this meeting was basically look at spectrum, 5G spectrum and zero trust networks, and trying to figure out exactly how we're going to address zero trust networking challenges. Now, I look at it for zero trust networks in a sense in two separate categories of looking at what I call internal and external agents. And I think you see a lot of that within the discussions that were going on this week. One of them is really with respect to spectrum and the physical layer, which is the external agents in a sense to provide zero trust. For example, do you have enough trust to have your information flow through the network? Do you have enough trust that the information is not going to be compromised? Do you have enough trust that it's going to be the typical CIA capabilities that we think about for trust, which is confidentiality, integrity, and assurance? And we heard a lot about that, about trying to look at different ways of addressing that problem by looking at dynamic spectrum, looking at, I think Milo mentioned earlier about the end-to-end encryption or tunneling issues, and looking at also diversity issues and trying to see if they can help you in the sense of these external agents. Okay. However, you also have to think about that there's internal agents as well. And we didn't talk a lot about that today in this week, but we may want to think about that. And that is when you assume that you have compromised hardware or software, or that there's analytics that is being taken, that's taking place at the boundaries, that we hear some things about supply chains trying to say they're going to take care of this. And trying to secure those supply chains one shape or the other. We either secure those by requiring a particular supplier. We can actually look at distributed or heterogeneous systems. That was discussed a little bit. And we've talked about open source as being it. But what it tried to do is it tried to make the sense of methodologies of not having an insider versus dealing with if you have an insider to begin with. And so that is one of the aspects. Is we've had projects when I was working with some of the people at DARPA talking about insider threat, right? And how do you actually deal with that? I know we don't like to talk about that, but if you're talking about the military, it goes overseas. It does a lot of things where we don't have control of the network. So it's different if you're in the United States versus someplace else. And so that's one aspect that I kind of got out of this that we were talking about. One other thing I like to talk briefly about is when you're talking about operations that people are doing overseas around the world, you have to start taking a look at the global marketplace and the equipment providers. This is more like the insider threat and alike. And that because of the global marketplace, you're not going to be able to determine all the different providers that are going to be an impact to any one network that you might use. You might be able to control that in the United States, but you may not be able to control that elsewhere. And so the question is, when we talk about some of these issues, we need to not talk about them just for the United States. We need to talk about them globally, because you're going to operate globally. And how are those things? Maybe some things that we actually put in place here may not be available there. And because the United States doesn't drive all of these economies, like they don't drive all the materials and the components and the chipsets and the device and the subsystems, we're not going to be able to control all of those pieces. So the question is, how do you actually address it when you can't control it? And that you're going to have to be able to understand how you work with a system that is not trusted, and that you have to be given up certain capabilities. And the one way that I think about this is something I brought up at the FCC TAC many years ago, which is I see a lot of what we do today, and a lot of the meetings material was building a better castle. And we would build higher walls, we would build thicker walls, we would build, a lot of different things, but that actually didn't solve the problem for castles. They had to put archers up there. They couldn't be just defensive. They had to be offensive too. And so the question is, when you start talking about zero trust networks, what's your offensive side of that? And finally, I'd like to leave with one other comment, which actually Blair brought up, and I just wrote down here, which is your incentives for security. One of the basic problems is the value proposition for securities, especially for capital markets. You have a timescale problem. You have to do a lot of work to make sure that you have security, but people are only interested in it when something bad happens, and then it's actually too late. And so the timescales of developing security challenges are definitely completely opposite of the timescales that are necessary.
Great, thanks, Paul. Just to pick up on something, we'll definitely get back to incentives, but I was really interested, and this goes back to what Blair was saying about zero trust, which is people don't want to hear those kinds of words.
Mm-hmm.
When you said, the insider threat, something that Lisa Porter said on Tuesday was, after Edward Snowden, everybody in government understood the insider threat, and it became a lot easier to talk about zero trust. To what extent is that threat something that the general public or just, your CTO, CIO in some Main Street company have to think about? Or is it going to be under the hood, under the...
Right, you faded out there. Under the hood, under what?
Yeah, so is that always going to be a hidden engineering problem that those untrusted experts deal with?
No, it actually, I think it has to be somehow formalistically looked at, because it's going to get much, much trickier as time goes on. And what I call the insider threat is two pieces. One is the individual, so it's the flesh and blood insider threat, and it's also the equipment insider threat, who is going to actually put something there, either a person putting it there or just because of how you buy equipment that it's there. I mean, both of those have to be addressed. Thank you.
Great, thanks. Doug, over to you.
Thanks, Pierre. So I've agreed a lot with what I've heard so far on this panel. I'm going to try to take it in a couple of different directions, and hope this is useful. So my first comments aren't really, they shouldn't, I don't mean them to sound like a criticism, but I think this actually indicates how early we are in thinking about zero trust in the application to spectrum management and wireless networks. What I was hoping to see out of this conference was a bit of a roadmap, how zero trust is going to apply across all of the types of spectrum users, and what this might mean from a technology perspective, how we could inform public policy. And I don't know that I saw that. I saw bits and pieces. But the reason I mention that is that I think the concepts of zero trust will apply very differently depending on the application to the use of the spectrum. And really understanding that might actually help us think about what policies might help bring some of this into focus. When I think of what traditionally ISART looks at, a lot of these things are a bit outside of scope. I'll come back to that in a moment. I also wonder, when we talk about zero trust in this domain, whether it causes any complications or rather complement spectrum management efforts that are underway. And at best, they would be, zero trust would be orthogonal to it, but I'm not clear on that. And that was another thing that I had hoped to really understand, kind of walking through this conference. So again, not a criticism, rather I'd say a challenge. I'd like to see more of that. I'd like to understand how these things actually fit. And picking up on a topic that was talked about a lot, the meaning of zero trust and whether we really are talking about zero trust is an interesting concept, because much of spectrum management is based really on trust. And maybe it's not even trust, maybe it's faith that things will work as they're supposed to. And overtly conservative faith in the design of the protocols and the assignment of spectrum. But what we're talking about, obviously, is something that's further up the stack necessarily, and really shifts to crypto constructs that we can't have faith in because they're provable. So, but I believe that this applies to a more narrow aspect of what we usually do at ISART. When I think of ISART, I really do think of things in the area of spectrum management and metrology and interference mitigation, a lot of these sorts of things. So understanding what any of this brings to the classic problems of interference with GPS or interference with radio astronomy or anything else, or whether any of these have differences in their application, I think would be very useful thing to understand better. I guess I want to also take a step back and touch on some of the things that Blair mentioned. We clearly have a broken model of spectrum management at the federal level, and things have gotten worse. I do wonder what we can do within ISART and any of these conferences that we're doing that might improve this posture of science and measurement and engineering as it applies to these national needs. And I do hope that one of the things that we think about as we start thinking more about security is how that fits in to the economic rationale and to the national needs rationale. As was said, security is often this attribute that comes only in emergency, only in when we're worrying about it, rather than where it should be in the planning stages. But if we can't get those incentives right, and we can't think about how some of this applies and where it applies, we won't be able to actually have that kind of coordination and management at an upper level. And that brings me to one other thing, and somewhat more controversial. I do see a strong need for a higher level of coordination in spectrum management, and that's something that I hope that we could see going forward.
Follow up on something you said about, one of the things you were expecting that you didn't see was a roadmap, and that's probably because we're so early. And that's one of the things that surprised me over the conference. We've done a number of conferences on this, is that security, forget about zero trust, just worrying about jamming, sniffing, spoofing at the radio layer. If you compare it to cybersecurity and the endless conferences on cybersecurity, radio networks do seem to be really late. Why?
Do seem to be really
late. I mean, we are coming to this late. The thinking about resilience, about security seems to be very far behind higher layers in the network.
Well, I mean, in some way that's the case. In some way, a lot of the aspects of the problems that have been solved in the wireless space as it relates to security are unique, and in that sense, it's not surprising that it's later. However, many of the problems that get identified as security problems are really reliability or resilience problems, and have a different application and a different way of being solved, and solved at a different layer. When I think of a lot of the stuff that's going on right now that's interesting, I see some really wonderful hardware that's coming out and software that's coming out that's not being talked about even here, that could have a profound impact on improving resilience of the networks at the radio level. We are seeing the ability to suppress interference with adjacent links in ways that we couldn't do before. Anti-jamming technology and other things that are coming out really complement this issue of what we think of and how we conflate kind of link and physical layer availability with a lot of the other security things that go up the stack. I would love to see ISART, for example, focus almost entirely on that. What can we be doing at the physical layer to really improve those links and the resilience and reliability of the link? And that's not to say that we also shouldn't be, you heard my complaints a couple of weeks ago. Zero trust is inherently a multi-layer issue. It's not a five-layer issue. So we need to be thinking about much more. And Milo talked about that earlier. So I think I would say that the challenges in the radio space are unique enough that, and conflated with problems of link reliability, that they're unique.
Thanks. David, over to you.
Okay, thank you, and great to be here at ISART. I'm going to say a few words about virtualization, then dive into zero trust. As with others, I'm speaking for myself and as a research guy and not for VMware's product team. Something we haven't been talking about these past few days is the role virtualization and software-defined networking will play in improving the robustness and resilience of 5G. The essence of virtualization is the recasting of physical resources so that they can be safely and dynamically shared. In the 5G core, virtualization will not only bring enormous cost savings, it also allows us to isolate the network functions, monitor their internal operations, and interpose on the flows of data in and out of them. It also allows us to implement network slicing and microsegmentation. All these are key enablers of zero trust. We're also going to push many of these benefits to the RAN as we take vRAN to the CU and eventually to the DU. Going out on a limb now, I think you asked us to do that, I think of spectrum sharing as a step towards virtualizing the spectrum itself so that it can be dynamically shared. Eventually, we'll go beyond sharing spectrum between government and commercial use. We're going to extend the concept to facilitate the dynamic sharing of spectrum amongst operators. We're going to have to find a balance point between providing enough fixed assignment to incent infrastructure build-out and enough to dynamic assignment to allow spectrum to flow to where it has the highest utility. So getting to zero trust, I want to address the conundrum. Why has this event focused on zero trust spent so much of its time talking about network robustness and resilience? In computer systems, zero trust is focused on protecting users or organizations from having their data fall into the wrong hands. Milo Medin did a great job of describing this in this morning's panel. To recap, users and organizations assume the network is compromised and can't be relied on to ensure data security. The network doesn't inherently trust users, their devices, peer networks, administrators, etc. But, and here's the big but, zero trust networking doesn't address availability. And that's the reason for this week's apparent contradiction. Availability is the reason we've been hearing so much about robustness and resilience. So how should we think about availability? Let me divide this into two subcases. I think this is part of what one of the speakers was asking for. First off, Dr. Porter's characterization of zero trust means we can't count on perfect availability. Bad stuff happens. So all the talk of having the 5G network host real-time control over vehicles and factory automation, et cetera, things that can lead to loss of life or property if they go wrong, that stuff's nonsense. If the stakes are really high, engineers don't design systems that depend on real-time wide area connectivity. Instead, we deploy systems that work better when there's connectivity, but are backstopped by a failsafe that doesn't rely on that connectivity. This suggests we should jettison some of the 5G requirements that combine extremely low latency with extremely high reliability. Engineers won't rely on them anyway, and as Kumar Balachandran said on Tuesday, every new performance requirement is a potential risk. Okay, so the second subcase is more subtle but more interesting. There are many less urgently critical systems that depend on connectivity to facilitate their efficient operation. They have more relaxed requirements, but our society will not function for long without them. This is the soft underbelly we need to worry about. Even though we can't count on perfect availability, we need to be able to rely on some imperfect form of availability. The good news here is that instead of trying to have fully trusted networks, we can relax some of the constraints. As Milo described, we use zero trust networking to protect the data itself. That takes a big challenge off the table. It means the networks focus on their key role, which is to move packets from A to B. And they don't need to be perfect at doing that. They just need to do so with a high enough probability to keep applications functioning. And that's why the 5G work on improving robustness and resilience we've been hearing about this week is so important. As William Webb suggested on Monday, we don't even need any one network to obtain that statistical availability. We just need to be able to count on the ensemble of network operators to provide an acceptable degree of resilience and robustness. I view the need for a probabilistic model of availability as being a special case of Dr. Porter's call for risk analysis. If we can statistically characterize availability, then we can let zero trust networking and end-to-end application thinking carry the water from there. So finally, I just want to emphasize another point that was made on Monday, the need to distinguish between small outages and big ones, and to have a separation of concerns with respect to how they're addressed. Operators will deal with the local outages the customers complain about every day, but operators, regulators, and government agencies need to work together to guard against widespread and especially against multi-operator outages whether they're malicious or accidental.
Thanks, David. Just trying to make sense of what you said, and when we're about to just do another round, and I'd like all the panelists to just take the opportunity, if they want, to reflect on what everybody said. But one way that I'm trying to make sense of part of what you said, David, was zero trust is perhaps not the right term. There's been a lot of contradiction and complication around it, and we should think more about availability. Is it a means versus ends distinction? That actually we should be talking about the ends we're trying to achieve, availability, not the means, zero trust?
Well, I guess I'd go to, I think Lisa's comment that zero trust was more a philosophy, right? And kind of a defensive approach. And I think that's the bucket you want to have it in. Now, in the networking world, we talk about zero trust networking, and that's a mechanism, right, to protect data in the presence, of bad actors. But I guess my observation is you're still going to need some degree of availability, but you don't need perfect availability. So, it's that zero trust philosophy leads you to saying, let's not count on perfect availability. But I don't think it can take you all the way to saying, gee, I don't need anything at all, right? For certain extreme cases, I was identifying things like the vehicle or that factory where somebody might die if you don't have connectivity in the short term. You just shouldn't do that. You need to have a backstop. But for many, many other cases, we can rely on something softer and have this more statistical form of availability. And I think that's something that our community can deliver.
Very good, thanks. So let's just go back. Blair, do you have any thoughts off the cuff prompted by what you've heard in the last 20 minutes?
No additional thoughts, so I certainly appreciate how everybody moved into a lot of different topics. It's a very robust discussion.
Paul?
Actually, I want to comment briefly. I mean, what David put together there and discussed, I agree and disagree, and I think it's kind of an interesting area, which is what are you trying to have at the end point? Sometimes we're now moving to more levels of autonomy. And so now the question becomes, there's a trade space going on there for availability and autonomy and what latency and like that you need. And I think that we tend to forget, we tend to be so focused on our problem that we don't ask the question, what's the application? And is there things at the edge that are happening that makes the network not as critical anymore?
Thanks. Doug, any thoughts?
Sorry, I was on mute. No, I agree with the other panelists, and I was pleased to hear that I wasn't confused with the narrow scope of zero trust. I had mentioned this to you, Pierre, that we were kind of applying a narrow problem to a narrow solution to a wider problem, and again, I think it's interesting, but I'd like to know exactly what problems does this solve for us here? And that would be probably one of the most redeeming aspects of this conference, to know, okay, well, what do we get out of that? But I agree completely with David in terms of availability, and kind of the robustness of the link is distinct from what this provides.
Yeah, I think this is one of the questions that I'd like to circle back to everybody right at the end of our session is something like, what should we have called the conference? If it wasn't zero trust, is it a naming issue or is it a substance issue? It sounds to me as if what I'm hearing from you guys, that it's a substance issue. Let's just get to a few questions. Let me just a reminder for folks, you can click on the Q&A button on the right of your screen and put in questions there. If you see a question you like, click the like button. That will help me sort them if we get lots of questions, which I hope we do. So the next thing that I want to get to, and one of the reasons why we had Blair go first is that there was pretty much a consensus that we all just want to cue off what Blair had to say. So I'm going to cue off something else that Blair was saying, which was this distrust of experts, which we've seen. Personally, I think that there's actually a lot to that, and I guess I can say that because I'm STEM educated. The way I was thinking about it is, it's always good to start with an Einstein quote, even if Einstein didn't actually say this. And the thing that came to mind that I stumbled on recently was he said that the intuitive mind is a sacred gift and the rational mind is a faithful servant, with the implication we need both. So we've had a lot of rational analysis so far this week. And, that's where I imagine all of us operate. But my challenge to you is when you think about this field and when you think about your reactions to the conference, what feelings come up for you? How do you feel about all this? Do you feel excited? Do you feel frustrated? So, Ashley, since nobody's answering, I will just call on. Go ahead. Go ahead, Blair.
Is that I feel kind of malaise.
Mm-hmm.
And the reason I feel malaise is because we're thinking about we're still in the 1980s and we're trying to look at problems the same way we looked at them then, which is understand them, evaluate them, try to figure out what the solution is. We're being typical engineers, which is great. Engineering is the first step that you do. But then there is not that innovation, I hate using that word, but looking at this at a different perspective and asking the question, where are we going toward? And sometimes we tend to be looking at where we are versus what is going to happen over the next 5 or 10 years with these technologies, and ask the question where we should be trying to position ourselves, not necessarily. In fact, we should be talking about 5G. We should actually be talking about what's beyond 5G, or what is 5G going to enable us to do to be able to address this problem.
So, I mean, it sounds to me as if you say malaise, which is a lovely word, you're bored, but it also sounds like you're frustrated that we are being myopic. Is that right? And
yeah, go Doug.
Oh, I don't want to. I thought Paul was going to answer that, but I wanted to say I'm concerned, and my concern is really, and if we narrow it back down to 5G, is just the cost of doing business from an OpEx and from a CapEx perspective particularly. What we have going on and how we manage spectrum, I think, is broken, and it would take some interesting leadership to kind of move out of the ruts that we're in, I think, in the spectrum management perspectives. And this also goes back to Blair's comments about the discord that's going on within the federal government. All of these things cause me concern that there isn't leadership to kind of move us beyond the battles to have a national perspective on what 5G is and what it could bring. But my concern is actually, again, the cost. Blair mentioned at the beginning, which is it's going to be have and have-nots. And that's a very unfortunate thing when we think about it going forward. This is where government should be stepping in.
Any other bidders? Let's have David first, and then we'll go to Blair. David first, and then.
Yeah, so, when you ask about emotion, I'm going to say I'm excited, right? That, in the sense that, we're going to have this ability to deliver a gigabit, or at least some fraction of a gigabit to people wirelessly, and that means we can deliver basically all forms of content of whatever resolution wirelessly, and that's just a huge change. Now, having said that, I also have concern in terms of that the researcher in me is excited. From a longer term basis, it's great. From the nearer term, I think I'd agree with Doug and some of Blair's comments, which is nearer term, there's concern over the economics of this thing. And I'm particularly concerned about the economics of millimeter wave. And whether or not it's actually really ready to deliver economically at prime time at scale. So we may need a couple more breakthroughs there, is what I'm basically saying. I'm also concerned that we've got the overall economy, which might be headed towards another drop. So we could end up with a rerun of 3G, which you may recall the adoption cycle, the story ended up great in the end for us enthusiasts, but the adoption cycle was much longer than people expected, created quite a bit of economic hardship for operators, et cetera. So, that's that combination of enthusiasm long-term, concern near-term.
Blair?
Yeah, just following up on David's comments, I think it's really important that scientific and technical work continue no matter what else is going on in the world. And yet we have to acknowledge that the year 2020 is going to be remembered as the year of COVID. And one of the things that COVID demonstrated really quickly was that in a world of remote everything, there are lots of people who will not thrive. And that it's not only about not getting worse. I mean, it's going to get worse. And what we're going to see, and just I could point to numerous examples, we're going to have millions of school kids who normally would go through what's called the summer slide, by which they mean, you stop your reading level wherever it was in June and come back to school in September. It's now back to March. Well, they left school in March, and when they come back to a physical school, if they ever get back there, they're going to be way behind in their reading. And we have all this wonderful technology, and yet we're not utilizing it to solve that problem. And let me put that problem in really concrete perspective. Every year, educators get together and look at what are the fourth grade reading levels. And with just that one data point, they can predict with unerring accuracy the prison population 11 years later. That's going to be a huge problem because reading levels are going to be way down. And my point is not in any way to criticize this kind of work. I'm just saying we have to keep in mind both the importance of constantly pushing the envelope from a scientific and technical perspective to build greater resiliency and growth into the economy. But we also have to understand that what COVID demonstrated is that we really can't have two different economies. We're all now on the information economy, but for those who aren't on it, we have some bigger, we as a society are going to have much bigger problems than we might have anticipated.
So Blair, I take your point about the haves and the have-nots, and others have raised it, and the
connected
problems, that COVID has highlighted that we have.
Yeah.
For the audience of this conference, what would you say to us? What should we be doing differently given that?
Look, if I had a good answer to that question, I probably would have already given a talk on that or written something on it. I do think that that the kind of scientific and creative expertise, there are good reasons, and this goes back to the whole question of incentives. We tend to do those things which capital markets are incented to produce, and capital markets don't effectively drive toward equity. That's not their job. But that is, in a way, part of the job of the government. So I don't exactly know the answer to that. But what I would simply say is we have to figure out ways of creating incentives for this community to solve some of the other problems. And if the systems aren't secure, nobody wants to use them. And I love the timescale the definition of that problem. But we also have to think about if we're going to essentially advantage lots of folks to be able to do certain things, we have to continue to look at what does that mean for society. And what I think this is, we dealt with this with the disabled community. If you build it in up front, you lower the cost by enough so that you can include lots more people. And we have to try to figure out, are there analogies to that to make sure that the changes that we're doing reach everybody.
Great. So I'm going to take a few of the questions in the Q&A. I imagine that we're not going to get through all of them. I apologize to people whose questions don't get asked. I would encourage you to take your questions with you into the breakout rooms. To just follow on this disquiet and concern that a number of you have raised, I want to combine two of the most recent questions. One was, it may be important to think about the economic and regulatory imperatives around system features. In the case of the questionnaires, like making it more trustworthy. So, what are the carrots and the sticks? A related question to that was, if we're expecting government to step in, isn't that asking for the impossible? Isn't government part of the problem? How should we be thinking about the role of those institutions? This is a jump ball. Wave your hand and start talking. David. David, you're on mute.
Thank you. Different location of the mute than I'm used to. Something that I've kind of come around to over time is transparency can go a long way. So if, in other words, if the government, helps ensure the collection, the dissemination, et cetera, of information on the trustworthiness of systems, that then becomes a mechanism, and a basis on which companies compete. The information's out there. Company that's doing well can trumpet that forces another company to respond. So having seen sort of many ways in which regulation fails, transparency, I think, is a really good step.
Okay, Paul.
Yeah, actually, it's a good question because I've been trying to look at analogies and where do you have regulatory effects and where can you actually build market value for these inverted timescales, meaning a very big issue that occurs very rarely, and then you have to have a lot of investment. Chemical industry tries to do that, pharmaceutical industry tries to do that, but the issue is that they've made it large enough that of a community that they basically flatten the curve. That those spikes don't occur because many of the spikes occur, and they flatten them out over time. I think regulatory comes into play when the spikes are so infrequent that you try to find some way of leveling them off. That way could be maybe liability, maybe, or an advantage. So somehow, how do you provide an advantage to somebody who does an investment, right? So that when a problem occurs, like this insider threat or whatever, we want zero trust, that it actually, if they've done the right thing, they get some kind of market advantage. To me, that instead of having a stick, I'd rather have that carrot where they can say, hey, they can look at the market, can look at the probability of event, and then try to actually fit this in as risk benefit ratios.
Is there anything that's preventing the market from doing that now?
I think it's
transparency. Sorry. Go ahead, Paul.
Okay, so let's
transparency. Make it really apparent when somebody screws up.
Okay, so that's one of the things that came up in a number of panels. Thank you for that cue. This point about transparency. One of the topics of one of the four pillars of the conference was data collection, measurement, observation. That's something that ITS has always done. And one of the things that came up, two related questions. One is, if we're going to be collecting all this data, different people are going to be collecting this data, but the value is greater when it is shared. So how do we incentivize sharing? So any thoughts on that? How do we make data that people need to train engineers or build better systems available to everybody?
So this gets back to my earlier comment, which nobody ever wants to hear, which is, this is the role of government to be, helping or encouraging or obligating the sharing of this kind of data. But I would argue that I don't even know what data we need to collect, or let alone how to collect it. So if there is some fundamental metrology that needs to be going on here to get to the heart of what's happening. When I look at the national broadband work that launched the early work in measuring broadband access speeds, there are so many ways of doing that now. And each of these has their strengths and weaknesses. And even just coming to a core set of understanding would be an important first step, which is, how do we measure this thing? And in parts of computer science, we have this very, very well agreed upon. There's whole areas where we understand what it means to measure, and we have test sets for doing it. But We really don't have much of that in this space, and we certainly don't have a way of collecting or sharing it at this point. And there was a time, as Henning and others pointed out earlier, that the federal government did collect this data, and that was gotten rid of. In my early days, when I was chairing the steering committee for NRIC, we were still collecting data and looking at outages, and much of that is gone, or it's been so weakened and so made not transparent that you can't get your hands around it, and that's a real problem. Data consumers don't have access to data, let alone public interest groups who would actually probably process that data and give signals to consumers based on it.
Go ahead, Blair.
Yeah, no, I think this is a really important point, and I would argue that in an information economy, the government should look at itself as needing to make sure that it is a repository of common, reliable, relevant information that markets have no incentive to collect. And it's not clear to me that the market really does have incentives to do this. One way of doing it is to essentially have the government say to industry, we're not going to tell you how to do it, but there should be an industry-driven group that ranks, for example, security. Now, part of the problem of that kind of process is that you can, well, if you do security, should you do performance? Should you do price? Should you do, there's a number of different factors. But at the end of the day, I mean, I think that is actually the government decision. What are those kinds of things that should be ranked? Some years ago, there was an effort that really was both a kind of a public and private effort that ranks the energy use of a building. So we have the LEED system, which, tells you whether you're in a building that's energy efficient. That did lead to those buildings getting a better rent. And in the same way, if you had networks that were ranked by security and there were big office buildings, who knows what the future of office buildings is, as we all are doing this from our homes. But still, to have kind of like a 1 to 5 ranking, it would arguably lead to the higher rents and stuff like that. So government doesn't have to do all the details, but government absolutely has to do the job of making sure that certain kinds of information, security be one of them, that information is collected not only at the time of the emergency, but on an ongoing basis. And one of the problems, frankly, that I think the FCC has is that as we got into the post-96 Act competitive world, the mindset was, well, now we have competition. Competition takes care of all problems. And I would argue that, well, it doesn't really take care of the problem of information. Effective markets depend on information. And yet there's lots of incentives to not give consumers information. And government, it doesn't need to price regulate, it doesn't need to do a lot of other things, but it should give better information.
Thanks, Blair. David, you had a point? You're muted. There you go.
Yeah. Actually, I think Blair just about along the way covered, a lot of those points. One thing I'd say is sometimes the government, I want to actually, I guess, emphasize one of Blair's points. The government may only have to give soft nudges. So, for example, when it funds academics to, get started, say an academic does an initial benchmark, that often leads to an industry group. Now the interested parties start realizing, we're going to get judged. Next thing you know, you've got an industry group where different parties are collaborating on that benchmark. So, government, I think in some cases, Blair, you're absolutely right. In some cases, it should be the source of the authentic data. In other cases, it may be able to just, nudge in various ways. And academia and research can play a big role here too. I will say, like NIST and, NTIA and these organizations have played very big roles over the years.
Thank you. Paul, before I turn to you, I just want to throw in something from the Q&A which came up, which is when sharing data. So this is more of the technical question than the regulatory engineering, regulatory institutional. When sharing data, how can we verify the accuracy of the combined set of data when it comes from different sources? And also, and this is a question that a panel yesterday took a hard pass on, how can we ensure privacy? And I'll add, do we have to worry about the wiretap laws? Paul?
Wow, that was a great setup. That was exactly where I was going. I'm actually all for transparency, and I want to collect lots of data. And usually, if it's just the four of us that are on this panel, we're collecting the data, I'm sure it will be done correctly, and we would keep it private. My biggest issue is that it's usually one generation after us or two generations after us who have all this data that actually, with all the analytic skills that we have been developing in this country that people have made hundreds of billions of dollars on, the question becomes, how do you prevent those kind of skills being applied to the data? I think there's a great research question there, meaning can there be homomorphic processing to get information on this? Is there technologies that can be developed so that we can collect all this data to get all this transparency, but to somehow ensure that you're only answering the questions that you're allowed to answer or ask, excuse me.
So David, if you could just make it short, we could probably talk for 2 hours.
Yeah, I just want to point folks at differential privacy. So one of the few places we can do well, we can say something grounded in math about privacy is when you're talking about aggregates of data. So there's some really pretty work there.
Yeah, wonderful point. Took the words. So one of the things I'd like to move on, we've probably only got about five minutes before we start wrapping up, is the question of complexity. And actually, this is also partly a cue for thinking that David has been doing about AI and machine learning. Another supposed Einstein quote is, everything should be made as simple as possible, but not simpler. And since I'm not an engineer, it's not clear to me whether that rubric was observed when the 5G architecture was developed, but clearly we're introducing a lot of new services. We've already had a quote, Kumar has been quoted, every new performance requirement is a potential risk. Milo and Wayne yesterday talked about the biggest threat that they see is complexity management. So how do the panel think about the problem of complexity management when trying to have a resilient, robust network, and what we should be doing going forward about that? Go ahead, Dave.
Well, one aspect, reduce the requirements, right? Clearly helps. But the other is, this is the space I'm actually really optimistic about. In the kind of cloud side of the world, we've got a lot of new approaches to automation. It's not just about machine learning. In fact, it's about declarative methods where, the operators describe how they want the thing to behave, and the system is automatically nudged by continually measuring present state versus desired state to where it needs to be. And, we've actually gotten pretty good at this. So, complexity is something that engineers, master. That's our job.
Oh, okay. So about 10 seconds. I think you have something very interesting. DARPA has been trying to do something exactly in this area, which is actually the question, how do you create complexity for your adversaries? You be able to deal with the complexity on your own. Given the tools and some of the research, that could be a very interesting process. It's almost like doing the same thing you try to do with cryptography, is try to understand how do you use that kind of asymmetry to your advantage.
One of the things that I want to go back to, and there are a couple of recent questions in the chat, is just about this whole question of zero trust again. Let's just keep worrying away at that a little bit. There was one question, which is, does zero trust imply that zero trust is needed to preempt a cybersecurity or warfighting arms race? And is it realistic to expect that to happen? And a more general question, is zero trust a critical technical topic? Or is it a statement that resonates with general trends in society? Blair, I think I'll start with you, since I think you said right at the top that zero trust does not resonate.
Yeah, it is a term that automatically raises the question of trust, which is one that I think most consumers don't think about. And therefore, why are you kind of it's almost as if you had a hamburger. McDonald's is trying to sell a hamburger that's like almost safe. It's like, why are you talking about safety in hamburgers? Or it's like you want to assume that kind of level.
But do we end up as a community misleading or lying to users if we pretend that something is trustworthy that isn't?
No, it's a great question. I don't know how to answer it. I think there's, one of the things that will happen over this decade is that we will continually see market forces drive certain technologies in ways that have short-term financial gains, but have long-term issues, such as not building in these levels of trust, but where kind of the liability is. It's kind of like, well, if you lose, you go bankrupt, but if nobody notices, you make a lot of money, sell it off to somebody, and you get out before you're caught. Government institutions currently are not operating in a way to do that. We are, most institutions in government are still operating the way they were back in the 1950s. Yes, they all have websites now. The websites aren't always aren't that good. So the government doesn't have the technical expertise, and whether it be questions of AI or 5G or many other things we can think about, we need to have institutions that figure out how to create the appropriate incentives to be fair. I raise that question about zero trust because it's really counterintuitive, but I don't think I have a solution to it.
Go ahead, Doug.
So I said this before. I'm concerned that we are misapplying a very legitimate security mechanism, zero trust, to a bigger set of problems. It's not the silver bullet for all security end all. It's a way of approaching these interfaces and these boundaries where there had to be some trust put in before that we now have other mechanisms that we can rely on. And in some sense, it's real trust. It's you're taking something from you're taking something up a level where it's verified. But this is a very narrow set of problems that it solves, and that's why I said it's not a panacea for wireless. That was my point at the start of my talk. So
my question for you would be, Doug, how would you frame the problem we should be looking at?
Well, I think it's the traditional problem of what are all of the threats and risks that we see across this space from if we are focused on security, and how can we mitigate as many of them, the ones that are of the highest caliber. Do I believe that 5G is going to expose more surface and lead to more attacks? Yes, I do. I'm not as optimistic maybe as David there, but I do believe we'll see some an increased set of opportunities just because of the surface area and the complexity. But with that said, that's me looking through it from kind of the penetration testing perspective, something that I do a lot of that I play around in. That's only one aspect of security as well. There's so many things to be considered in this big bucket of what you worry about as a secure network, secure wireless network. And again, we still are conflating it with all of the availability issues at the physical layer. So I think if we don't parse those out, we'll be kind of confused in what we're discussing. And I certainly think that zero trust is a worthy thing for us to be pursuing, but we also have to realize what it applies to and what it doesn't apply to. And that's why I thought it would have been useful at the beginning to say, here's what we're doing as a roadmap for wireless.
Thank you very much. So we've got 10 minutes left, so I'd like to just do a wrap up, and we'll go in reverse order. David, we'll start with you, and then we'll go to Doug, Paul, and Blair. But my question for all of you, and of course, you can talk about whatever you want to talk about, but my question for you is, what do you think is the most pressing question that this community should be addressing going forward. Another way of framing it is, we're going to have to make good decisions going forward. We're going to have to pick research areas. We're going to have to pick technologies. What are we lacking in order to make those decisions? So David, over to you.
Well, I'm not sure this one, hits the mark on most pressing, but it's coming at us really fast. There's wide open questions around the use of ML within the network. Particularly the kind of ML machine learning that everybody's really excited about are these deep neural networks. And the catch is we don't understand how they work. And if we deploy a technology, I should actually say people are now looking at using these things really deep within the bowels of the network, for congestion control, for dynamic spectrum allocation, for all sorts of things that are really in the real-time aspects of the network. And if you embed in the network something where you don't actually understand how it works, and you don't in some other way constrain it, then inevitably it's going to surprise you. It's going to fail when it gets unexpected data, and adversaries are going to attack it. So, this stuff is coming very fast. It's coming towards the real-time aspects of the network. There are ways to constrain and reason about how this works. Even if you don't understand it, you put it in a box and you wrap constraints around it. We need to get there, and we need to establish that as good engineering practice.
Thanks very much. Mr. Sicker.
So the question was, what is the most pressing question?
Is it by any chance a roadmap?
Yeah, exactly. That was one of the things I said earlier. And the other reason I say a roadmap is because I think it matters what spectrum user you are and what your concerns are. I agree with David that ML and a lot of the AI tools are coming down. The ones that I'm seeing applied in the wireless space, I think, are pretty well bounded, and I think we understand how they work fairly well. I've been playing around in that space. My concern still is, why are we not adopting technology that's out there that could improve some of the situations that we know are happening? And maybe that's an incentive problem, and understanding those incentives of what we could be doing. There are things that we could do in the radio astronomy space to protect them better and kind of isolate them. And radio astronomy is very different from GPS. I think we can all agree on that GPS really needs to be protected in an interesting, different way. And so what can we do to move ahead on some of the wonderful research that's going on? And this is another thing that was brought up before, which is this kind of idea of what's the horizon of research, and are we going to get stalled? I don't see it at this point, but maybe there'll be a feedback loop in terms of suppressing research dollars. At this point, we have so much pent-up research that has been done looking at solving so many of these problems that have not been really adopted in the wireless space, and that's a curiosity to me. I spent my last 5 years playing around in the terahertz. That's still way out. So we have a lot of work that's pent up, ready to release as the need comes. But again, I still wonder why we haven't gotten more. And I'm not talking dynamic spectrum access. I'm talking fairly straightforward adoption of technology that could better share spectrum. And I wonder why that is. And that's an open question for me that I think speaks to the need of kind of some roadmap thinking about future use of spectrum.
Thanks. Paul.
I'll take this a little different. I like to try to get the incentives right. And so I'm going to try to say that maybe there's two real simple questions if we can try to answer. And that is, how do we get the incentives that the consumer or the user is actually the one who wants to drive this? Meaning you had your security software, right, for your computer. Why? Because when you ran it, you actually saw all the viruses it took off your machine. So there was a feedback mechanism that gave you that you had a problem, your machine slowed down, you used this virus software, and eventually took care of it. So I want to ask the question is, how do we try to make the application layer drive the diversity of the network in a sense, is how to move the security to the user. How do you actually get the user to have the knobs to actually impact their own capabilities and their own security? And the second one, which is really similar, which is how do I drive that by getting the consumer? How do I give the consumer the tools to be able to measure security in their own right? So that way they can actually ask the question, give them this feedback, give them this transparency that we're talking about, basically to understand that they have a problem, they are at risk. Now they may not, they'll make their decision if that being at risk is important or not, but at least it will get us as a research community to start thinking about, with all those knobs that are now on the network, maybe some of those knobs should be pulled out of the network and not be just the MNO operating, but that the user operates on them.
Great, thank you. Blair, over to you.
Yeah, I would just follow up on that. I think that that's a really important insight, which is how do we think about it in terms of the tools that consumers get? And I would just end by saying that that's unlikely to happen unless there's an intermediate government institution or some other kind of trusted nonprofit institution whose motives are to achieve that, but who may not have a financial stake in the game. And I think that that's part of the problem that we see in a variety of different fronts. I'll just close by saying it was fascinating watching the big tech hearing, the antitrust hearing a couple of weeks ago, where if you were an antitrust lawyer, you might have said, well, wait a minute, why is this guy raising privacy? That's not really antitrust. Or suppressing conservative voices, is that really antitrust? But the point is, the public, the government, and the kind of folks that most of the people on this call are working with or for, we have to figure out better ways of giving people tools so that they do trust it. And what you saw in that hearing was, in really what is a remarkable change, I think, from 10 years ago, again, when Doug and I were working on the National Broadband Plan, there was enormous trust in the companies that no longer exists. And I'm not pointing to specific companies, but there's just a level of distrust that makes it much more difficult to I think, move forward the way we should.
All right, thank you very much. We're getting close to wrapping up. And one of the things that I was interested in listening to all your comments, actually, but particularly Paul and Blair at the end, was talking about the user and the consumer. And I think one of the things that we haven't had a chance to look at is what are the primary threats by the user type. So there are end users that are military grade. So right at the beginning of the session, early on, there was a question, is it really important at all to think about military grade jammer resilience in military networks? Given what we know about 5G systems today, how much is good enough? Does anybody want to speculate about partitioning the risk tolerance or the threats to different kinds of user groups? Nope.
Well, Pierre, of course we do that already. I mean, that's just kind of how it's done.
And so, who would you say is most vulnerable, Doug?
To what?
So presumably, so let's think about risk. You've got high impact, low frequency risks. You've got high frequency, low impact risks. They will be different for different groups. Who needs most attention to be protected from risks?
Well, you know that risk is this kind of exposure, and what's the probability and what's the impact, right? We tend to organize around that, and organizations that have a lot to lose are the ones who are going to be most sensitive. Some of the stuff with movement towards 5G and how we move up into the core of the network and the potential, broadening of the impact of an attack might make consumers more interested in what it means from a security perspective. But clearly, the military and the government and others are going to have a much higher bar. When I think of classic attacks in the network, what it tends to focus on are high resource, high dollar mark resources, and this could be healthcare, this could be credit cards, this could be any number of things. But again, you need to, before you even take any attempt at pinning that down, you have to define what that, what is the actual threat, what's the attack, and who's the target. I think the question about does 5G systems need to have, I think you said military grade anti-jam or something? Of course not. But the military does need military grade anti-jam. So.
Very good. And with that, our time is up. I'd like to thank all our panelists. One of the drawbacks of being virtual is you can't hear all the applause, but just imagine all the applause. My apologies to everybody whose excellent questions did not get answered. Please take them into the breakouts, which will reconvene in 15 minutes. And with that, I will hand it back to our day moderator, Keith Brempen.
Well, I want to add my thanks to Pierre and the panel. That was very interesting and gives us all a lot to think about. So before our breakout session, I'd like to welcome back Cheryl Jenko, the director of the Institute for Telecommunication Sciences, who has some closing remarks to close out this fabulous ISART 2020. And just as a reminder, remember to join that set of breakout room. It'll be fun to get your questions directly. Cheryl?
Okay, thank you, Keith. Audiovisual guys, can you hear me? Great. So the focus of ISART this year was on 5G and a zero trust network. Wow, even the title's controversial. That makes for a very good conference. It was the 20th ISART, and I want to thank everyone. We sparked new research and ideas and thought through this last 4 days. I want to recognize the fact that we had a breadth of participants. We had government, industry, and academia. This was not a scholarly exploration, but a practical exchange of ideas and how to operate safely in a 5G world and beyond. In the panel we just heard, a lot of conversation about whether or not we need a roadmap or a vision for zero trust, and that'll be some interesting thought to go through over the next years. We started out the week by setting a baseline with tutorials and the current state of 5G. That was a fantastic set of workshop, and I want to thank everyone who presented and attended. We opened the next section with setting the stage. We had talks from NTIA, NIST, and CU. And in fact, Terry Vries from CU made me really want to go back to school. Some very, very exciting things happening at CU. I don't think I'll be going back for another PhD, but it was very exciting. We heard from Joe Evans in our keynote address, who is the technical director for 5G at the Office of the Secretary of Defense. And he provided significant detail about how the DoD is approaching 5G and zero trust. The next day, we framed Zero Trust Today. The panel gave a deep dive into what we thought zero trust means within the spectrum world and the known risks that existed today at the intersection of 5G new radio and zero trust. There was a lot of excellent conversation in the breakout rooms during that particular day. And, as we just heard in this panel, a lot of conversation about whether or not a zero trust world is a liability. What does it mean? Is it necessary? There are many, many things coming to share that perspective as we go forward. 5G design, resiliency at the radio layer. As you all know, ITS has a long history of radio engineering and testing, and it was particularly interesting for me with my background. And in that section, we took a deep dive into the current state of open radio access networks with various technical presentations and a very lively set of conversations. 5G deployment came next, implementing secure and resilient solutions. explored how to implement secure and resilient technical solutions in a rip and replace world with the zero trust environment. So an overview of supply chain verification problems and possible solutions, which I thought was very interesting because it came from the EM side channels and included the RF detection of malware. So again, I particularly was vibing with that section because of my engineering experience in that area. We saw NTIA's own Jay Chabray outlining all the things that are happening in the government, and that made my head spin. I might have to go back and look at her video and sort of try to learn more about what she was talking about. Thank you, Jaysha. 5G is certainly more attention related to security than LTE had, but this attention also has led to some advances in security overall. So during that session, one of the takeaways that I actually texted out to my family and friends was that an attack occurs within 3 minutes of a new IoT device attaching to a network. That was amazing to me, and that alone was a significant outcome of that deployment section. Went into 5G monitoring and data collection and the feedback loop there. Monitoring data is the nexus of feedback loop among design, deployment, and operations, and could be the key to securing the 5G radio layer. Doug Boulder gave us an excellent presentation, I felt, on the presentation of spectrum monitoring, the importance of understanding that from the RF side, the intersection of the vast array of data. This was sort of something that is also very near and dear to me, because then we saw a whole series of data that was collected from the air from Mark Gibson and Northeastern University. The data collection and the platforms at Northeastern University also made me want to very much attend school again and dig into that. We discussed AI and machine learning as a double-edged sword. Often actors with, malignant intent do bad things, but they can also be deployed as white hats to detect and mitigate threats at far greater speed and resiliency than normal human intervention. Big data is definitely an area of exploration, and various places have put data sets online, including ITS and others, and we're looking forward, all of us together here at ISART are looking forward to understanding more about how new big data, ML, can possibly help us with our future research. 5G operations and implementing resilient zero trust networks came next. As with 5G monitoring and data collection, we saw the intersection of spectrum monitoring and sharing, and looking forward to how we can collaborate with the many opportunities that give us many challenges. John Shea recognized this in his presentation of the Coliseum work that they're doing there. Significant value was brought up in the panel and the mixture of different types of information, and our previous panel, just before my speaking, really touched this. It's sort of the intersection of the network, the physical location of the endpoints, user roles, responsibilities, and many, many other pieces of information allowed that will provide us a coherent and real-time understanding of the use of the network that we need to create. Our panel, esteemed wrap-up. I was very much interested in the idea that not only is it the network that we are trying to secure, but bad actors, good actors can take many types of analytics on this data, and what do they do with the analytics? We touched upon the ideas of security, of private information, and what is done with the aggregation of data, and really something to be understood in the years to come. Another piece that came up in our just previous panel was this idea, I hadn't thought of it before, but this idea of the time scale of security problems versus the time scale to protect. And that is really what made me scared. I mean, they talked about a malaise or a difficulty, but that was a little bit interesting, because if we don't get moving on this, we're going to be behind the 8 ball as a country. I thought there had to be a challenge that we drove down. I think it was Doug that talked about a roadmap. I think it's more than a roadmap. I think it's a vision of how we apply across applicants for use of the spectrum and how different users of this spectrum might apply zero trust. So with that, I want to just recognize that I think this week we definitely advanced innovation in communications technologies. We informed each other, and we investigated some of our nation's most pressing telecom challenges. I want to recognize the fact that we will be sending out a survey to those of you who participated this week, and we really want to hear your input. We know this is the first ever video, and everybody wants to visit us in Boulder, and we would love to have you and host you here next year if it'll be possible. Over the next months, we'll begin to think about ISART 2021. So your survey and feedback will be very important, and we will take it seriously. The slides from all the presentations are being posted and linked to each speaker on the website and on the agenda page. We've received a number of inquiries about if and when videos from ISART will be available. And, there have been many important discussions this week. And we will be posting the videos on the ISART website soon. But we must comply with federal regulations and posting videos and including captioning. And it may take us some time. We hope to make them available within the month. I want to thank the honored speakers, the moderators, the thought leaders, participants. I want to especially reach out to all of you who had excellent questions not only in the chats, but in the breakout sessions, and made this very much virtual interaction worthwhile. I want to particularly shout out to Howard McDonald and Pierre Vries, whose questions made me think almost every single session. So thank you, gentlemen. Again, to Keith Grembin, Pierre DeVries, Hatfield from CU, Terry Fries, thank you for co-hosting. Thank you, NIST, for co-hosting, Melissa Midzor. NTIA, ITS, Rebecca Dorch. Let's all give her a virtual applause. Amazing, amazing. Andy Thiessen, co-chair, and Lily Segure, who was instrumental behind the scenes and helping us get all these fantastic speakers. My thanks wouldn't be complete without thanking the audiovisual team at Conference Services. Nice work, seamless. I sort of gave up all control of my life to this audiovisual team, and it went smoothly. Thank you. Now, please remember, join our last set of panelists in the breakout rooms and chat with the polymaths about all of the things that we've just. We'll see you at ISART 2021. Have a safe, inspiring, and productive year. So long from Boulder, Colorado.